Okay, next problem. We're going to first rewrite. We're going to rewrite this in radical form. Rewrite in radical form. Okay, so we're going to start off. Let's have y to the negative 2/5. I'm going to rewrite that in radical form. Okay, well, first off, anytime I have a negative exponent, remember you could send the entire thing to the denominator. So that's going to be 1 over y to the 2/5. And now I just rewrite that in radical form. So I can put this is the type of root, this is the index, so it's the 1 over the 5th root of y squared. Or remember, I could put the 2 on the outside. 1 over the 5th root of y, all in parentheses, squared. Either one of these is going to be okay. Either one of these. They both have different uses for us. So that is that. Now, what happens if I've got like a decimal here? Well, first off, you want to change this. Let's change this into a fraction, and I think we should know what 7.75 or 75 hundredths is. But you can always just use the change it to a fraction. So 75 hundredths equals 75 hundredths, and then you reduce divide by 25, or sorry, divide by 25, and we get 3/4. So we get x to the 3/4. That's just going to equal the 4th root. Don't send them underneath, it's not negative, of x cubed, or the 4th root of x, and then the entire thing cubed. Again, either one of these is okay. All right, so what if we go the other way? Let's rewrite now. Let's rewrite in rational exponent form. Let's rewrite in rational exponent form. Okay, so we're going to go the other way. So let's say I start off with something like the square root of a cubed. Well, I know that this is a 2 here. It's a square root. So I'm going to have a to the, let's see, the type of root always goes underneath. So it's going to be like this, a to the 3/2. That's a 3. It's kind of hard to see. 3/2. Okay, what if I have something like 5th root b squared? All right, so I know it's a 5th root, so I know it's going to be b. The 5 goes underneath here. And don't be fooled. Remember, the 2 can be on the outside or in here. Doesn't matter. It's going to be b to the 2/5. So either case, that's how we rewrite. Now, finally, let's get into some more interesting simplification problems. So let's simplify. All right, so again, method 1, if you can change to radical form. Or method 2, you want to rewrite it so that the exponents, let's see, simplify. Okay, so 2 different methods. Sometimes we can use one or the other easier. So let's simplify. For example, let's do 8 to the 2/3. 8 to the 2/3. So method 1, I could change it to radical form. So that's the cube root of 8 squared, right? Or I could write that as the cube root of 8 squared. Either way, remember the 2 can go on the inside or the outside. It doesn't matter. You could either get the cube root of 64 or the cube root of 8 squared. I think this one is usually a little bit easier to work with. So the cube root of 8 is just 2 squared. So we're just going to get 4. I mean, you would have gotten 4 this way too, but I think it's a little bit easier to work with this one. Okay, method 2, I can rewrite so the exponents simplify. In other words, let me start with 8 to the 2/3. Start with 8 to the 2/3, and notice that I want this 8 to be written as something to the 3rd power. I'm going to rewrite this as something to the 3rd power. So let's rewrite that as 2 cubed to the 2/3. Why do we do that? Remember, if I take a power to a power, you multiply these. So really, that's saying 2 to the 3/1 times 2/3. Remember, you multiply when you take a power to a power. 3/3 just makes a 1. So you're left with 2 squared. 2 to the 2 over 1, which is 2 squared, which is 4.